So
This conference will now be recorded.
what was the first feature? Simple and easy to understand. Yes. Okay. So when why I am saying sorry. So why I am saying Python is simple and easy to understand? Because it is developed how? Developed using what? Using basic character set. Using basic character set. What was basic character set? After A to Z, small a to Z, 0 to 9, and all the symbols and all those things, right? So these were the things that we say that Python is developed, right? Okay. And then, as I told you, Python is high level language. Python is high level language because of this reason only. Okay. So and termed as what? And termed as high level language. Termed as what? High level language. So whenever I'm saying high level language, it is based on what? It is based on what? It is based on the simple character set tokens, or you can say components. Okay. Now what is the next thing I told you? High level languages must be converted into low level. High level languages must be converted into low level. So high level languages must be converted into what? Into low level. Into low level. Using what? Using compilers or interpreters. Compilers or interpreters. Yes or no? Compilers and compilers or interpreters. So depending on the programming language, basically. So depending on the programming language, this conversion will take place. So yesterday I told you one example wherein we took the number 63, right? What we took yesterday? The number 63. So 63, actually 63 is like base 10. Why, sir, you are saying base 10? Because it is a decimal number. It is a decimal number. Decimal number. It is decimal number. So decimal number means what, sir? Decimal number means the numbers that are formed by the combination of 0 to 9. The numbers that are formed by the combination of 0 to 9. Okay. Now I want to convert this into binary. Okay. So I want to convert this into what? Binary. So how can I convert, sir, generally? Generally we convert by using the division remainder theorem. By using what? Division remainder theorem. So division remainder theorem means what, sir? So two, yesterday we just used calculator, but today I want to just give you the description of how it does, right? So 2 3 6, and what is remaining here? 1. So 2 ones 2. So what is remaining? 1 is remaining. Okay. Next, 2 15s. Simple mathematics. 2 15s. What is remaining? 1. 2 sevens. What is remaining? 1. So 2 threes. What is remaining? 1 again. So 2 ones. What is remaining? 1. Okay. Now I'll say 2 zeros. 0. What is remaining? Okay. I think 2 sevens 14, 2 3 6. Okay. Correct only? Okay. So now binary number means 1, 1, 1, 1. How many ones here? 6. 1, 2, 3, 4, 5, 6, followed by a 0. Okay. So minimum, how many I told you? Minimum 8 bits. So minimum 8 bits means it is a positive number. Positive number means you can keep a 0. How a negative number is converted later on we will discuss. We will not go into a confusion state. Okay. Getting my point? So this is recognized as what by the system? This is recognized as a collection of elements. This is recognized as what? 0, 1, 2, 3, 4, 5, 6, 7. What is this, sir? 0th bit, first bit, second bit, third bit, fourth bit, like this. Hope you are getting my point. Now how it is 63, sir? Can you prove it? Yes. Now what we'll say here is, this I'll say 2 to the power of 0. This I'll say 2 to the power of 1. This I'll say 2 to the power of 2. This I'll say 2 to the power of 3. This I'll say 2 to the power of 4. This I'll say 2 to the power of 5. This I'll say 2 to the power of 6. This I'll say 2 to the power of 7. So decimal to binary. Now we are again just rechecking. Is it 63 only or not? Means I am converting binary to decimal. Binary to decimal. Okay. So 2 to the power of 0. What is the bit here? 1. 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 What is the bit here? 0. What is the bit here? 0. Right? Okay. Now tell me 2 to the power of 0 into 1 is how much? 2 to the power of 0 is 1. 1 into 1 is 1 plus. 2 to the power of 1 is how much? 2. 2 into 1, 2 plus. 2 to the power of 2 how much? 4. 4 into 1, 4 plus 2 to the power of 3, 8. 8 into 1, 8. So 2 to the power of 4, 16. 16 into 1, 16. 2 to the power of 5 how much? 32. 32 into 1 is 32. Okay. 2 to the power of 6 is how much? 64. 64 into 0. So 0 only. So 2 to the power of 7, 128. 128 into 0, 0. Now just add it. 32 plus 16, 48. 48 plus 8, 56. 56 plus 4, 60. 62 and 63. Got it? Verified. Understanding my point? Yes. So you also have seen something. Now what is decimal number? Tell me. Decimal number means, just we'll have the idea. Okay, once we'll have the idea, then we can move on to the next feature. What is decimal number, sir? The number formed by the combination of what? Combination of 0 to 9. 0 to 9. Any big number you take, it will be a combination of 0 to 9. So we will call it as a decimal. Decimal means what? 10. Decimal means what? 10. So in childhood we have seen, right? To the base 10. 63 to the base 10. Whatever number you take, decimal number, so it will be to the base 10. Mathematics. I'm talking about mathematics. Yes? Okay. Now what is binary number? So binary number means the number which is found by the combination of what? 0 and 1. Only 2. Only 2. So minimum of 8 bit. Maximum it can go 8, then 16, then 32, then 64, like that it can be. Is it clear? Okay. And then what are the other types of numbers, sir? Octal number. What is the other type of number? Octal number. The number that are formed by the combination of 0 to 7. The same 63, now I'll convert into, so this is base 2 actually. This is what? Base 2. Now I will say 63 to the base 10. I want to convert into base 7. I want to convert into base 8. Base 8. Why, sir, base 8? Why base 8 we are saying? 0 to 7 means how many numbers? 8 numbers. Octal. Octal means 8 only, no? Okay. Now how the conversion will take place, sir? We will divide by 8. We'll divide by what? 8. 8 eights is 64. But 8 sevens 56. 64 means more, no? So we'll take 56. How much is remaining? 1 is remaining. 56, 7 is remaining, right? Okay. Now 800. So the answer is 7. So how can I write it now? 7, 7 and 0. 7, 7 and 0. No need of 8 bits here because it is octal. So computer can convert into decimal, binary, octal. It's up to its wish. I mean, it's up to its architecture, right? Its architecture. It depends on architecture. So it may convert into octal. It may convert into binary. It may convert into, next one is hexadecimal. Next one is what? Now you understood how the conversion took place, sir. How can you reverse it, sir? Okay, let us reverse it now. So 0. This is very important discussion because all these things we will convert into programs later. So at that time, there should not be any confusion. Okay, this is 8 to the power of 0, 8 to the power of 1, 8 to the power of 2. Obviously, this is 0, 1, and 2. You can think like that. Okay, 8 to the power of 0 is how much? 1, sorry. 1 into 7 plus 8 to the power of 1, how much? 8. 8 sevens, 8 sevens, 56, no? Okay, plus 8 to the power of 2, how much? 64. But 64 into 0. So 0 plus 8 sevens, how much? 56. 7 ones, how much? 7. So what is the total? Done? Got it? Okay, so that is what it is. Then finally we will talk about hexa. This is not a new stuff, already we know, but we are doing in programmatic, I mean in view of program. Okay, hexadecimal number. So what is hexadecimal number, sir? Hexa 6, decimal 10, 16 total. Okay, now the numbers that are formed by the combination of 0 to 9 and A, B, C, D, E, and F. What is this, sir? A, B, C, D, and F. So now 0 to 16 total I told, no? So 16 means 0 to 15. But I cannot say 1, 0, 1, 1. Then again the confusion will come. So that is why we use capital A or small a. Anything is okay. Is my point clear? So what is A now? Literally, A is 10. A is how much? A is 10. A is 10. Okay, what is B now? B is going to be 11. B is going to be 11. So what about C? C is 12. Okay. Studying my point? So D is how much? 13. Okay. Then what about E? E is 14. Okay. So what about F? F is 15. Understanding my point? Yes or no? So 0 to 15 literally. Yes? Okay. Again we'll take same 63. 63 to the base 10. I'll show you in calculator also, don't worry. So base 16, how the conversion will take place now? So you have to divide by 16. Okay, 16 2 is 32, 16 3 is 48, 16 4 64. So 16 3 is 48. That's it. Okay, if I'm wrong in calculation, you can please tell me. So 48 minus 63, how much? 15. So 15 means what? F. It means what? F. Okay. So 16 0 0. So the remainder is 3. So what is this number now? Z F 3 and 0. So generally we keep it as 0x. 0x. Okay. So 0x or 0 capital X, no problem. Is that clear? Yes or no? Okay. Now just I will open the calculator. If you observe here, the same 63. Now see on the top. So what you observe here? So 63, what is binary 63? What is binary 63? So binary 63 is nothing but 0011. That is what we have here. Yes or no? Okay. Then what about octal? 77. 7 and 7. So there should be no confusion. That is why we kept 0. Okay. Right. Then what about hexadecimal? 3F. Done. So in this way, we look at the types of numbers. Very, very important, because we are going to do programs on this later, not now. When you get to loops and all, we will do it. Is this clear? Okay. Now this is our conversion, but we cannot convert everything, no? So who will take the responsibility of conversion? Compilers or interpreters. Now what is Python? I told you yesterday. Python is a interpreted language. What is Python? Python is a interpreted language. So whenever I'm talking about Python, so what is Python, sir? Python is a interpreted language. So what is the second feature that we need to talk about? Python is an interpreted language. Python is a interpreted language. So why, sir, why Python is an interpreted language? Because it converts line by line. Who is responsible for that? Interpreter. Okay, so first what we'll do is we'll talk about compiler also and interpreter also. Okay, so we'll talk about both because both are important. So compiler. So what is a compiler? A piece of software, a piece of software that converts a source code. Converts a source code. So source code means what, sir? Whatever we are writing. We wrote so many programs. No, what we wrote? We wrote the source code. What we wrote? Source code. We wrote the source codes. So source codes we write. We write the source code. So source code. So that source code into a machine code. Into a machine code. Machine code means what? It may be binary, it may be hexadecimal, it may be octal, depending on the architecture. Is that clear? Okay. So into a machine code or a, so in case of C actually, in case of C, in case of C programming, in case of C programming, or a byte code in case of Java, in case of Java. Getting my point? Okay. Now what you are trying to say, sir, here? Okay. Now let's say I am a C programmer. Who am I? A C programmer. If I am a C programmer, I will write the source code in which language? C language. Okay. So I will write here C language source code. What I'm writing? C language source code. So generally C language source code will be something like program.c. Program.c. Right. Now who comes into the picture? We wrote high level codes. The high level codes must be converted into what? Converted into low level. So low level we will generally put it as zeros and ones. We generally put it as zeros and ones. Who is responsible for this? Compiler. Now the OS will link this and OS will link this actually. OS will link this and get you what? Get you the output. It is as simple as that. Now you understood? You are not responsible for converting like 63 division. No, no need. So who will do that? Compiler will do that. In case of C. Okay. Now let's say you are a Java programmer. Okay. You are a which programmer now? You are a Java programmer, let's say. Now what you write as a Java programmer? Java source code. Java source code. Now here also who will work? Compiler will work. Who will work? Compiler will work. So what the compiler will do here, it will not directly convert into machine code. It will convert into byte code. What it will convert into? Byte code. One byte is 8 bits. So it will convert into 8 bits and all. Right? So group of 8 bits it will convert. Is that clear? Okay. Then there will be interpreter. There will be interpreter. What interpreter will do? Interpreter will convert into machine code. Interpreter will convert into machine code. So interpreter responsibility is to convert into machine code. Who will be linked by? It will be linked by the OS. It will be linked by the OS. So linked, and what you get? You get the output. Is this crystal clear? Yes or no? So C is only compiler based language. Java is okay. So basically the program will be program.java. Is this understood? So Java program will be converted into bytecode using a compiler. Then later on, who will take the responsibility of conversion? Interpreter will take the responsibility of the conversion. So that conversion is made to what? Machine code. What is this code? Machine code. Getting my point? So you don't have to know much about bytecode here because you are not a Java programmer. So for a Java programmer, I need to make them understand the bytecode also. But for you, not required. Why? Because 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 Python is only a interpreter. Okay, we will write here. So we'll write how the working of a compiler does. So working of a compiler. So what the working of a compiler, sir? It converts it converts the code using blocks. Using blocks. So it converts the code using blocks. It is as simple as that. Is that clear? Okay. So blocks. Understood? Okay. Then coming to the interpreter. So what is interpreter, sir? Interpreter is also a piece of software. That's it. It's a small software that is available with your installation. As you install Python, interpreter will be installed. As you install Java, compiler will be installed automatically. We don't have to do anything. Okay. A piece of software, a piece of software used for converting the source code into machine code. Okay, in case of Python, yes or no? Internally, it will do all the conversion. As I told you, we don't have to worry about. We only see the output. That's it. We only see the output. Yes or no? We only see what output. So directly we are looking at the output. That's it. Okay. Means now you are a which programmer? You are a Python programmer. You are a Python programmer. So Python programmer will write which code, sir? Python code or Python source code. What is the name of this? .py. .py. Okay. So after this, what you are doing? You are going for the interpreter, and what that interpreter will do? It will convert into directly machine. Yes. Generally, people say bytecode also and all, but I don't want to say all those things. Okay. So because we never look at the bytecode, right? In this particular thing. Okay. Right. So this is machine code. And what this machine code will be? It will be linked by the OS. And we will get what? We will get the output. Now you understood why Python is interpreted language. So working of an interpreter, sir, it goes line by line. Working of a interpreter, it converts the code line by line, line by line. Okay. So at the end, who is fast? Compiler is fast. So compiler is used by C. Compiler alone is used by C. That is why C is fast. Now Java uses compilation and interpretation. That is why it is slower than C, but it is faster than Python because Python is going line by line. So it has to convert everything. So that is why Python sometimes can be referred as scripting language also. So line by line it goes. Right? Is this clear? Okay. So this is the second feature that we have to know. What is that? Python is an interpreted language. Now you got a clear idea what is compiler, what is interpreter. Yes or no? So whenever you are writing Python, in the background, interpreter will be working. Okay, interpreter will be working with the conversion. Is this clear? Okay. Next, very important feature again is Python is an object-oriented programming language. What is this? Object-oriented programming language. Okay. So generally we say OOP also. Okay. So before moving into this topic, let me ask you a simple question. Who are you? Full stack developer. Very good. So or you can say now student. So if you ask me the same question, I'll say I'm a trainer. So you are a student, I'm a trainer. Okay, so this is a bottle, this is a laptop, this is mobile. Okay, so what you are talking about? You are talking about the objects. Yes, okay, fine. Now basically we are talking about the physical elements, but that physical elements whatever are there, they must be in represented as a class. They must be represented as a class. Okay, in short I'll tell you, when I'm asking you who are you, you are saying me you are a student or a developer. Now you are referring a class, you are referring a class. So class is something logical, something logical. Let me make you understand. So now if I am saying I am a trainer, I am a trainer. Okay, so what I'm saying here, sir, I'm saying I'm a trainer means, what is this trainer? Trainer is my category. Trainer is my category. So programmatically, what is that category? Class. Yes or no? Okay. So I am a trainer. So here I am referring to, I'm referring myself. I'm referring myself. What I am? I'm an object actually. I'm physical. No, I'm object. I'm referring myself an object belonging to trainer class. Exactly. Yes. But what is this object-oriented programming language, sir? If I have to give a definition, what I can give, sir? Simple. An object-oriented programming language is a language which is depending on two things: class and object. Hope I'm clear now, right? So, what is object-oriented programming language? If somebody is asking you a definition, an OP language is a language that depends on that depends on two basic units of programming. Two basic units of programming. What is the first one? First one is class. Second one, object. What is the first one? Class. Second one, object. Hope I'm clear. So who is trainer here? Class. Now for example I will say you are a student. I'm referring to, I'm referring you. Who are you? You are an object, physical. Whatever I see physical, they are objects. Belong to which class? Exactly. Yes. Getting my point? Okay. Now for example, HDFC. HDFC is what? It's a bank. Now tell me who is object here? HDFC is object because we are looking at HDFC. Bank is what? Bank is its class. Hope my points are clear. Who is HDFC sir here? Object. Who is bank? Class. It's class. For an object to sustain, for an object to be there, class is compulsory. Without class, there is no object. Now there is no object in this world which do not contain to a particular class. You can take any example. Now for example, if I'm taking this, what is this? This monitor. What is this? Monitor. So means it belongs to this Dell is a monitor. Dell is an object which is belong to a monitor. That is AC. So what is that? Voltage. Voltage is an AC. Voltage is an AC. Whatever you see in this world, okay, whatever you see in this world, everything is a category that you represent. Yes. Okay. Okay, sir, give us a definition so that we can understand it easy. Okay. Now I'll give a definition for a class. Now I always say class is logical. Why, sir? Why you are saying logical? Okay. Now I said trainer, I said student, I said bank, okay, I said monitor. Now these are all logical. Why, sir, you are saying logical? Is there any student in this world with name student? Is there any trainer in this world with name trainer? Because trainer is his category. Student is his category. Yes or no? Hope my points are clear. Yes, class is logical. So what I can define a class? A class is a which entity? Logical entity. Class is a logical entity. What is a class, sir? A class is a logical entity. Okay. Here, an entity refers to, entity means what? Entity refers to, here entity refers to a person, place, entity refers to what? A person, place, thing, or an event. Or an event. What you create? You create persons. I'll tell you in real time point of view also. No. Okay. Now, for example, hope you're understanding my point. What is class? Class is a logical entity. What an entity refers to, sir? It refers to a person, student, place, bank, thing, monitor. Yes or no? Now, sales. Sales is what? It's an event. Sales, marketing. What are all this? All these are events. Okay, I'll give you a simple idea by using the use cases. Okay, so example use cases. Always it is good to have some examples. Now, for example, I am working on a student project, student management system project. Let's say I'm working on what? Student management system project. Okay, so in student management system project, tell me who will be the entities. Students. Suppose student management system means what? A student comes to the college, he will get a seat there, he will register, he will pay money. Yes or no? So he will get a library card. Yes or no? So whenever I'm working with student management system, tell me the list of classes that I can create here. I can create initially a student class. So for a student, lecturer is important, no? Yes or no? Lecturer. I'm talking about college. Okay, let's say college. Student, lecturer. Okay, I'll create a library class. Yes or no? So I will create a fee class. I'll create a fee class. Again, fee is an event. Yes or no? So library is a place. Student is a person. Yes? Okay. Now, suppose I'm giving him a laptop. On every admission, I'm giving him laptop. Laptop is what? Thing. Getting my point or not? So I'm giving him a Lenovo laptop. Now what is Lenovo? Lenovo is an object. Okay. Now tell me okay, let me put it a table. Hope you're understanding. I'll relate this to our course also. Don't worry. I mean course in the sense what we do in the future. Okay. What are objects now? Okay. So students say, so the student joined is like, okay. So student joined is somebody like Jitesh. So Jitesh is a student who joined the college. Who is object here? Jitesh. Okay. So lecturer. Lecturer of Jitesh is somebody called as Hari. Okay. So who is the lecturer of Jitesh? Hari. Okay. Now he is going into a book library, books library. So book. So for example, CSC book, or you can say something like DBMS book. Okay, or you can say computer library. Anything you can say. Yes. Okay. So fee means amount. No, amount is physical. So amount class or amount object, something like that. Is that clear? Amount, the currency basically. Okay, so I'll say okay, better is currency. Hope you are understanding my points. Yes. Okay. So I'll say currency. Right? Laptop. Okay, so he has given a Lenovo laptop. Okay, so somebody gave him a, or college people gave him a Lenovo laptop. Now you're understanding. Now suppose if I'm taking bank management, bank system. In bank, what will be there? Name of the bank. Yes or no? So bank class. So HDFC Bank, customer. Okay, again withdraw, events, withdraw, deposit. So like this, every project should have set of classes and objects. Am I clear? Yes or no? So like this, you work on classes and objects. So what is an object then? Okay, so here I'll write one more point on the class. A class is which entity? Logical entity. You logically can look at student, lecturer, library, fee, and laptop. So suppose fee of one student will be 30,000. Fee of other student will be 25,000 only. Yes or no? Difference will be there. No? Is that clear? Okay. Now, for example, if I am saying a class is a logical entity, so entity refers to a person, place, thing, or an event. A class is a blueprint. What sir? What do you mean by blueprint? Now, for example, in a particular college, there will be hundreds of students. All of them belong to which class? Student class. So those are all what? Those are all the samples of this blueprint only. No, original is student, but all those are the samples of the student class. That is why student is a blueprint. Hope you're understanding my points. Yes or no? So a class is a blueprint for creating. A class is a blueprint for what? Creating objects. Creating what? Objects. Am I crystal clear? Yes. Sir, give us object definition also. Okay. Simple. Object is what? You can say now. An object is a physical entity. An object is a physical entity. Am I clear? An object is which entity? Physical entity. Yes or no? Okay. Physical entity. So again, I don't require this. Now, an object is an instance of the class. In Telugu, if I say instance means amsham. So we are all instances of humans. Humans is a class. We are all instances of humans. Suppose if I am talking here, I am an instance of trainer. You're all instances of students. Dell, Lenovo, BenQ, all these are instances of monitor. Yes, getting my points or not? So Samsung, iPhone, okay, that phone, this phone. So these are all instances of phone class. Now you will not get any example without a class. Everything belongs to a class. Now what we do, sir, in real time, we will create these things only. Student management system means you will be working with student class, lecturer class, fees class. There will be so many links and everything. Hope my points are clear. So now the next question is how we can create these classes and objects in Python. Just I'll write a snippet of code, small code snippet. Now there is no need of understanding that. Later on we can understand it. Okay, but for now we will understand some of the classes. We'll understand some of the classes which we are going to use. Which are going to use. Okay. Now I will say here in Python we work with two types of classes. One types of classes? Two types of classes. Two types. What is the first type, sir? First type is built-in classes. What is the first type? Built-in classes, which are already there. The classes. So believe me, we already used the classes. I'll show you example also. Okay. So what we are working with, first type of class, built-in classes. Second one is user defined classes. Every programming language will have some built-in things. Every programming language have some built-in things. Now print you are using, no? Print was what? Print was a built-in thing only. It's not a class basically, it's a function, right? So of course it is also an object, later on we'll understand. Built-in means which is already there. User defined means which we will create for our project. Is my point understood? Okay. First, we will talk about built-in classes. So, what are built-in classes, sir? The classes that are defined in the already defined in what? In the program ecosystem. The program ecosystem. So previously we used to call them as environment and all, but nowadays we are calling it as ecosystem. Program ecosystem. Program ecosystem. Okay. So in the program ecosystem, we call it as I mean, which are already there, we call it as built-in classes. Okay. Sir, where did we use, sir? You are just saying we used it. Okay. Now let me say A is equal to 5. Okay. So what I'll say now? I'll say, okay, let me open up us environment. So now you don't worry about that. So just try to concentrate on what is class. Okay. Now, if you remember, I told you every element will have a type, integer, character, yes or no? Okay, if I'm saying type of A here, it will tell me 5 is an integer type data. Yes, again going back. So I told you, you remember. So when we talk about data, we have numeric data, we have character data, we have Boolean data. Yes or no? Okay. So, right. Now, here if you observe, I will say A is equal to 5. Now I'm saying type of A. So type of A, what it is saying? It is int type. Okay, fine, super. Now, int is an int is a okay. Tell me, what is your common sense saying? Int is a class. Who is 5? Exactly. Who is 5? Object. Suppose if I'm saying x is equal to 23.5, x is equal to 23.5, and I'll say print of type of x. What it belongs to? It belongs to a class float. Now, are these not built-in types, or did you create any class? 23.5, 44.8. Okay, so 5, 8, 9, 12. What are all these? All these are built-in. All these are what? Built-in classes. Yes. Is this clear? Hope you are getting my point. So, what is type of A? Okay. So, for your clarity, I'll also put it this way. Why sir? A also getting int and phi also getting int. Who is phi? Phi is an object which is stored to A. Hope my point is clear. Yes or no? Yes. So phi is which is stored into A. So what is A now? Int type. What is phi now? Int type. Phi int type is stored in A, no? Hope my point is clear. So this is how we deal with what? We deal with built-in classes. Built-in classes. So what are built-in classes? You understood now? What are built-in classes? The classes that are already defined in the program ecosystem. You don't have to create it. But what you can create, sir? You can create user-defined classes. Now it will not give student class, employee class, bank class. It is customer duty. I mean, it is the programmer's job to create. It will create only basic classes. It will give you only basic classes, what are important for the program. But the other classes you have to create by yourself. It gives you a program code to do that. It gives you a syntax to do that. Okay. Now the classes that are created, okay, by the whom? By the programmer. The classes that are created by the programmer for his usage or his team's usage. Team means the project team. Okay, so now for example I am a in charge of Python code, so there will be some DB code program, so he will also use this class because he want to store some information onto the database. He is also using that class, so for the team or for himself. How sir, how will you do that? Okay, I'll go for the example where I'll say class student. What I'll say? Class student. So just I'll say pass here. Okay, so pass means just nothing like that. Okay, because the code and all you might not understand. Okay, now I'll say class student. Okay, so I'll say pass. Now same thing I'll say. S is equal to student. S is equal to student. So what is S now? Okay, don't worry about that main. Main is like file. Okay, so main is that file. Okay, so don't worry about that. I'll just remove it. So student. So it belongs to which class? That main is that class name and that file name. Okay, is my point clear? So class, which one you have created? Student. What is S, sir? S is just like A. Who is object literally? This is object. Hope I'm clear. Who is object literally? Here A is assigning this object. Of course, you can call S also as object. Not, I'm not saying no. A also object. You can say no problem. But exactly speaking, who is the instance? This is the instance. Yes or no? This is the instance. So now, for example, if I am saying type of student, so what it gives you again? It gives you the same answer. Yes or no? It is giving you the same answer or not? Yes. So what it is giving you? It is giving you type which class? Student class. Understanding? Now, if you want to create, how can you create? Class followed by the class name. And internally, so many things will be there. For now, we will not talk about. We'll talk about this again in advanced Python. Okay, up to advanced Python, you just relax. We are not going to talk about this. In advanced Python, we will talk about this class and all. Okay, so maybe 1 month time. Okay, 125 days to 1 month time, we will talk about that. Is this clear? Now, why, sir? Why we are discussing then? We are discussing this because at the end of the day, you are going to use the classes. You are going to use the objects. We're going to use the objects. Objects are everything in Python. Yes. So now you understood the whole idea of object-oriented programming. Yes, object-oriented programming means what? The programming style which completely depends on two things. What are they? Class and object. Yes. Okay. And going further, when I say object-oriented programming language, so there are also some principles to talk about. There are also some principles to talk about. So what principles are? Principles of object-oriented programming. Now, for example, you go to a college. In college, what are the two important things? Students and faculty. These are only two important. The other things will be there: principal, HOD. What are all this? So, without these two, they are waste. No. So student and faculty are like class and object. It is simple గా చెప్తున్నా. I'm telling you in simple words. So other things will be there surrounding them. What are they? Principal, HOD, dean, director, that, this, libraries and all. Yes sir. So in the same way, besides class and object, we also have four principles. Yes. So they are inheritance. What is the first one? Inheritance. Inheritance. Next is polymorphism. What is the next one? Polymorphism. Inheritance, polymorphism. Then you have, sorry, abstraction. Then you have finally encapsulation. Again, these things we will be talking about in depth when you go to OOP. I mean, when you go to advanced Python. So we are first into core Python. No, core Python logics are important. Then we will talk about these things. Yes, these are very important when you go to Django. When you go to Django, these are the very important things that we need to know. Yes, without this, we cannot move to Django. That is why we talk about this in advanced Python. Hope the points are clear. Yes, so what I'm talking about here, principles of object-oriented programming, so which are inheritance, polymorphism, abstraction, and encapsulation. So the programming language which is dependent on, I mean, which is created using class and object. First point is that. Then the other principles supported are inheritance, polymorphism, abstraction, and encapsulation. If these are given completely, then only it will be a object-oriented programming language. Yes. And last but not the least point, so when you talk about object-oriented programming strength in Java and Python, Java is a little bit stronger. Java is a little bit stronger. Okay, we'll talk about this later. So Java is a little bit stronger in OOP features also. Okay, so that is where again Java will take an edge over Python. But anyhow, things are there in this here also. We will talk about them. Hope today's class you understood. So today the main thing was object-oriented programming, and we also talked about Python interpreter, and we also talked about compile. Yes. So tomorrow we'll have two more features. Okay. So with that features will be completed, and then we will go into the programming. Components we will start. Okay. Components. So we wrote some programs, but now we know what are the components we are using. What is that A called? What is that phi called? What is that equal to called? So all those things we will be discussing. Features also equally important. Right. Thank you.